Well, hello, everybody. This is Dr. P. Schubert. I'm picking up on Module 11 Counter. This was the challenge problem, which is due by Friday night. So, watching this, it's sometime on Saturday. Um, so, I'm going to pick up where we left off in the last video. This is where I kind of got my hint, which was in order to do this, you needed to rewrite them. And my suggestion was to rewrite them so that you were basically cutting across each of these. Because right now, you've got one section which has all the adult pairs. You want to spread them around. You should notice a pattern starting to form that's up here. Right? So you notice that when I take the last two digits, so I went through and took the last two digits, 00, 00, 00, 00, 00. Right? That's these two. And so I took the last two ones and made them the first two. And the first two go over here. Right? We have the last. So it's kind of like a good quote from Jesus. The first shall be last and the last first. I reverse the order of those. I also reverse the order of these other bits. So I'm just taking my state and I'm flipping this. Just taking them in a different order. Does not change what happens. Right? The order of the bits doesn't matter. This just happens to be a little bit easier because now I have X's everywhere, which is going to help me out. Now let's watch. If I walk through all the ones that are 00, the next state bit 01, 00, 01, right? 00, 01. So as long as from here it goes back, so right? 00, 1, 1, 1. Right? If it's 01, right? Then we go to 2. 1 goes to 2. 1 goes to 2. 1 goes to 2. Right? And then we hit the 1 goes to the end. So I can see here, these have all 2s. Right? The only thing that's ever going to mess us up will be this last one. Right? And I mentioned this because that's the 2 state. We're just about to hit that. Now we do the 2s. Right? And the last gets our 2. So 2 always goes to 3. We're just adding 1. Right? So I have 2 goes to 3. 2 goes to 3. 2 goes to 0, because this is the reset condition. Then 2 gets the X. So I have 3, 3, and it goes to 0. And then, of course, my 3s, you'll see 3 goes to 00, 3 goes to 00, then we have a 3 goes to X. Okay. And in fact, this last one, right, which is here, I get all X's across the board. So really easy to fit this last condition. Because I actually have 5 4 months. Right. So now all I have to do is get these last bits here. Right? And the last bits here start as the most significant. And if you watch 0, 1, 2, because we're counting through, right? These are the first ones, 0, 1, 2. So you would expect this pattern to also continue, right? So, but that's where they started. That's over on this side, right? 0, 1, 2, 3, 0, 3, 0, 3, 0. Right? So 0 goes to 0, right? But you'll notice at the end, this is where it flips over, right? I have, right, my 0 goes to 1 on the very last one. So we get that kind of roll. So on the very first one, I have 0, 1, and then 2. So that gives me my 0, 1, 2. Remember the order. Take a look at the next one, right? So we have 0, 1, and 2. Same exact thing. And then, of course, right, 1, 0 goes to 3s. It's the 1 zeros. So the first bit's 0. 1, I said we were always going to have somebody who makes an exception, goes back to 0. This is the one where all of this stuff happens because that's where my reset is. So it goes 0, 1, back to 0. You can also notice it because it's all 0, and so if you reorder it, change it. So 1, 0, 1, 0, it's right there. All 0, so change it. So the only one I'm missing now is 3, right, as my start spot. I've got 0, 0, 3, 0, 0, and then 3 all X's. So at least good. Right? So taking a look at my 3s. I have 1. So it doesn't start at 0. You significant bit comes for most. So 3s, I've got this one, 1. And then my 3s have 2. And everything else is X's. Yeah. 1, 1, 2. So I've taken this chart and rewritten it where I flip them and then reshuffle. So this was my original modulo 11 count. This is the modulo 11 recount, reshuffled. A little bit of room here. Now that I've rewritten my chart, again, the whole reason I rewrote the chart was because I wanted my muxes in 4 months, right? A 4 input mux, 1, 2, 3, 4. You can see that's the 0, 0 input, the 0, 1 input, the 2 input, the 3 input. But I needed each one of those to have X. The reason why is I used 0 and 1 as input. One, 2, 3. Right? 0, 1, 2, 3. So I've used those up. I have to find out these patterns here. Say what they are. The patterns that I have to go hit them on, I did have all zeros. I can do 4 zeros. If I have 4 zeros, or 3 zeros and X, or 2 zeros and X, I can call it 4 zeros. Right? So I have the all 0 pattern. I have the all 1 pattern, which is 4 ones. Right? So you'll see here 3 ones and X, and I can call that 4 ones. So I can have 0, 1. I can have a Q2 and 3 have not been used. So I can use Q2, which is 0, 1, 0, 1. I have Q2, which is 0, 1, 0, 1. The order of Q2. I can have Q2 prime, which is 1, 0, 1. The flip of it. And I have Q3, which is 0, 0, 1, 1. Notice both of those have the same pattern in each section. And I can also have Q3 prime, which is 1, 1. Now we have 6 possibilities. Now technically speaking, I've got 3 different variable spots. So there's 8 potential patterns that could happen. But there are some patterns I can't actually form here. In particular, I can't make the pattern 0, 1, 1, and then anything down here. I can't do that, and I can't make the pattern 1, 0, 0, something down here. You'll notice that I don't have, I have 2 zeros, but not a 1. Because all the other ones don't have that. I can't, the only spot where I've got 2 1s right here, but I can't have a leading zero. So there are 2 patterns I can't make. But if you look through this, none of those patterns appear. So I don't have to worry about it. Look at each of these over here walking through. I don't have a 0 followed by 2 1s or a 1 followed by 2 zeros. This doesn't occur. So I move on. Right? So it turns out that these two I cannot produce aren't needed, which means all these remaining patterns in here can be made by one of these 6 potential names, which takes 2 inverters. I'm going to need all of them. And then what I'll do is I'll have that go into my flip-flop, which has 3, 2, 1, 0, and then the Q's come out, make these like back values. So that gives me my next state area. So in any case, I'm not going to do these because I list the names here, and I'll list these ones. So let me do the first column. This first column is the first one I'll do here. I've got 3 zeros and X. That is my 0 now. I write it back into my next one. I'm writing down the column into 1, or the 1. I've got 3 1s and an X. So my 1 works nicely for me. I've got my 2. It's 2 1s and a 0 and an X. So if I look for 2 1s and a 0 and something else, awesome. So I've got my Q3 part. And then for 3, I've got 2 zeros and 2 X's. I actually have several patterns that can do this, but I'm not going to call zeros. Just round it. This is the simplest one to do, just round it. And so that does the first column. So that's the one hooked to D3. So snapshot, that's your first area. Then we'll do, let me see if I got enough. So I'll try to do these small. 0, 1, 2, 3. That's Q1, Q0. That goes to D2. That is the next column. 3 1s and an X. I pick 1. 3 zeros and an X. I pick 0. 2 1s, a 0 and an X. I pick 1 1 0 0, which is Q3 prime again. And then for 3, right, I've got 0 0 2 X's. I can pick a lot of different stuff here, but I'm going to pick 0 for all of that. I've now finished this one. 0, 1, 2, 3. So following the same order. Should make this bigger out. Just so I have room to connect these. And again, this comes up with icing. So now I am doing this column. 0, 0, 1 something. 0, 0, 1. Like that. I've got Q3. Next one, it goes into 1. 1 is 0, 0, 1. It's the same pattern that was on the previous. So I can hook Q3 to both of those. For 2, I've got 0, 0, 0 and an X. So I hook that to 0. And the final one is 0, 1, and 2 X's. Lots of choices. I guess actually I only have one choice. Q2, the only one to find that works that way. 0, Q2. I've got E0, the very last one. I guess I am lucky it will fit. 0, 1, 2, 3. I'm not saying this is pretty. And I'm trying to do it without erasing. Oh, so now I'm on the very last column, 0, 1, 0. That's Q2. We got X, so I can make the last one. I've got Q2 for the first one on 0. On O1, same pattern, 0, 1, 0. You notice in the next one, 0, 1, 0. Awesome. So the next three are all Q2. Matter of room, so I'm just going to write them. All right. 3 is 1, 0. This is the one that gave me trouble. If this one had a bend here, I could have actually, because I haven't used Q2 prime yet. But now I've got a 1 and then a 0. And if you notice, the only spot I've got a 1 and then a 0 is Q2 prime. So it looked like I could get away without having to use that final one. But right here at the very end, Q2 prime. Oh, wow. So this now completely solves that problem. I can now use 4 input muxes and 2 inverters, so I can have the size of my muxes and still build a modular 11 counter. Now, the trivial way to build a modular 11 counter, obviously, is have 16 inputs. And then I have a really simple design, right? All I have to do is just, into 0, run the number 1. Into, spot 2, I run the number 3, right? So you just take whatever the address number is on them. You have 16 spots, so just finding one number up. You hard fix them in place and stick them in. There's no calculation. They'll propagate through and be static, so you're just picking them. So it's really easy to do that if you have 16. But that's a really big mux. The homework problem has you cut it from 16 down to 8. The stretch problem counts it down to 4. Right? You get above that, you start getting all kinds of complex patterns. So you might ask, why did I come up with this? So this is actually a really old problem. I gave it as a practice problem back in like 2003 or something silly like that. And as shocking as this seems, I typoed when I copied it into the solution. And when I did that typo, I changed it accidentally from a 8 input mux to a 4 input mux. And so I had, solved this problem with 4 input mux with 1 inverter. And I released the practice out there, but I hadn't put the solutions out. I was working on the solutions, and that's when I noticed that I had a typo on it. I was like, oh man, well, maybe I can do it. I got down to that last one. I'm like, oh, I can do it. And then I discovered I can't do it. I tried a bunch of other permutations. I didn't go through everything, but I was like, darn it. So then I thought, wow, that's kind of cool problem anyway. So I gave them this solution, I gave them the other. And 17 years later, I'm now letting you be haunted by the same problem. So a typo generates a very efficient design. I'm not going to say it's a pretty design, but it's very good. Anyway, hope this is at least somewhat informative of some neat things. It does illustrate this whole idea of rearranging to get the X's, and that the X's allow you to make much more efficient patterns, which is behind a lot of design decisions. So the X's not only can help you with things like you get a K-map design, for instance, but here it helps us with things. All right. Hope you have a wonderful weekend, and God bless.